Now we will solve the sixth problem. Two radiations with the photon energies 0.9 electron volt and 3.3 electron volt respectively are falling on a metallic surface successively. If the work function of the metal is 0.6 electron volt, then the ratio of the maximum speeds of the emitted electrons will be. In which ratio is the question. So for this we are going to use Einstein's photoelectric equation. Okay, my dear students, what is Einstein's photoelectric equation? The incident energy E is equal to work function W plus kinetic energy. Understand? Plus kinetic energy. Or the same equation can be rewritten as E minus phi naught is equal to kinetic energy. This equation I am going to apply for the two photons. Okay, students. So for the first photon, E1 minus phi naught must be equal to KE1, and for the second photon, E2 is the incident energy minus phi naught is the work function of the metal, and KE2 is the kinetic energy of the emitted photoelectron. Okay, students. So for the first one, I am going to substitute everything in the same unit, electron volt only. So what is the first photon's incident energy is how much? 0.9. So E1, this is 0.9 minus, what is the work function? 0.6. So this is 0.6. So this is equal to half m1 or half m into v1 square. Mass of the electron is the same, so m1, m2 I need not denote, but the velocity of the electron will be different. Therefore, the notation is v1 here. Okay. Similar equation I am going to write here. What is the incident energy of the second photon is 3.3. So this is how much now? This is 3.3 minus work function is the same because metal surface is the same, is it not? So minus 0.6. And this is equal to half m into v2 square. Here also mass of the electron will be the same. The velocity only or the speed of the electron only will be different. So I will rewrite this. So 0.9 minus 0.6 is how much? 0.3. So this is 0.3 is equal to m v1 square by 2 or half m into v1 square. And here, so here 3.3 minus 0.6 is how much? 2.7. So this is 2.7 is equal to half m into v2 square. Have you understood, students? The direct substitution, because here we need not convert it into joule because the work function also is given in electron volt. Incident energy of the photons also are given in electron volt. So it's easy numerical. So I am going to divide the two equations. Okay, dividing, so that 0.3 divided by 2.7 is equal to half m into v1 square. So v1 square divided by half m into v2 square. So cancelling this half and m. So 1 by 2 and m get cancelled. So 0.3 by 2.7 can also be written as what? 3 divided by 27. I am multiplying by 10 on both sides. So this is now equal to what? v1 square, okay, by v2 square. Now 9 3s are 27, is it not? 9 3s are 27. Therefore, okay, therefore v1 square divided by v2 square is equal to what? 3 divided by 27 is equal to 1 divided by 9. 9 is a square number, no? It is 3 square. So taking square root on both sides, okay? Taking square root on both sides, the same equation can be written as what? v1 by v2 is equal to how much? 1 by 3. Because square root of 9 is 3. Okay? So now you see here what is the ratio of the maximum speeds of the emitted electrons will be. So V1 is to V2. V1 is to V2. So V1 is to V2 is 1 is to 3. Therefore V1 is to V3 is, sorry, V1 is to V2 is equal to 1 is to 3. So which is the option here? Option B is correct. So this is the correct option. Option B. This type of problem has been asked almost every year in JEE. Understand? And in NEET also. Have you all understood, students? Okay, fine. We'll go to the next sum.